This video introduces the basics of making predictions. Once I have a model, there are three things that I can do with it. The first is understand relationships between variables, and that involves the coefficients. The coefficients give us a translator between one thing and how it helps predict this other thing. So it gives us a scale for contribution of the predictor X to this thing Y. It can also help us understand variation among observations, that explained variance. So when we look at the R squared, we're getting an idea of how much of the variation in something we're explaining. So this is helping us understand this overall relationship. But the third thing, and maybe the most important in our business problem solving, is predicting outcomes. I don't just want to understand something, I want to see ahead into the future as much as I can and have a good sense of what's going to happen. Of course, that involves having a good model, so that's a requirement that we'll talk about soon. But making predictions is going to help me better manage a business or a business-related problem. In this video, we're going to learn how to make a single prediction by hand. Imagine that we have a model where we're going to predict how we score on an exam based on some intercept plus some measure times how many hours we studied. So our intercept is 50, and the coefficient in front of hours is 15. So we know that we can interpret that intercept by putting a 0 in for hours. So that would mean that the score equals 50 plus 15 times 0 when we don't study at all, which would be just 50 left over. That's what the intercept means. I studied for 0 hours. What is the average score that I would expect in that situation? Of all the people who have studied for 0 hours, their average score is 50. But now I want to talk about making a prediction. So for any value of hours, I can make a basic prediction about what that person's score might be. So to make that prediction, I would substitute any value here instead of 0. So I write 50 plus 15 times anything and get an answer. So I could study for 3 hours and see that my prediction is 3 times 15, which is 45, plus 50, which is 95. So in this model, my prediction for 3 hours of studying is 95 points on that test. If instead I study for, that's a 15, not a 1.5. If I study for 2 hours, I have 15 times 2 plus 50 is 80. So on average, the people that studied for 2 hours scored an 80. So if I study for 2 hours, I would expect an 80. Probably it'll be a 79 or an 82, or maybe it'll widely differ from 80. But my prediction is 80 based on the model. Now here we are in R, because we're never actually going to make a prediction by hand unless we're just back of the envelope scratching for a quick and dirty solution to a problem that we have. So the first thing that I'm going to do is import that data that I had from the scores. So I'm going to change my working directory to my desktop. And now I'll just read in that data set. Let me just check it out just to make sure that things look good. Okay, and the dimensions of D. Okay, so I have 100 rows and I have an ID for each student, the hours, the sleep, the previous grade on an exam, and that grade, the score on the exam. So let's create a model. Can't make any predictions without first creating a model. I'll call it fit, and we will predict the resulting grade, the resulting score, based on the hours spent. And we'll look at that summary. So here we are with the results. We see the intercept is actually 54.8, not bad, and the hours coefficient is about 4.8, 4.9 also. So thinking back to that paper example we did, we had an intercept of 50 and a coefficient of 15. Here it's a little bit different because this is based on real data. Now, how do I make a prediction? Well, R actually saves for us the values of those coefficients so we can do multiplications. So look at this. We call the model fit. We can look at fit $coef, and it prints out the intercept and the coefficient in front of hours. Fit is a variable. It holds all the information about the model, and that includes the errors, the coefficients, a nice summary that we look at, and all kinds of other special elements, and we can print them out at our leisure. If I look at fit coef, it's going to give me those two things together. So I'll run it from this side, prints out those two items. But if I just want one of them, I can look at fit coef 1 to get the intercept, or fit coef 2 to get the coefficient for hours. And once I have those coefficients, I can start making predictions. So if I want to predict the score of someone who studied for 4 hours, I could say, come over here, I could say fit coef 1, which is the intercept, plus fit coef 2, which is the coefficient in front of hours, times the 4 hours that that person studied. And this is going to do that calculation for me. And over here, the prediction for that person's grade is a 74.3%. So I could do that with any value. I could say fit coef 1, the intercept, plus fit coef 2, the coefficient in front of hours, times 7 hours, and find out what the prediction is. And I'll get 88.9. So the more hours I'm studying, more expected high score, and that's what we would expect with a positive coefficient in front of hours, like 4.87. I could also make a prediction for the first student in the data set. So let's look at that first student. That first student studied for 2 hours. We already know that the grade for that student was a 45, but we could still make a prediction, see how good our model is. Does it predict that the student's grade is a 45? Fit coef 1 plus fit coef 2 times, I could write just 2 hours because that's how much the student studied, but I could also write D hours 1 because it's the hours of the first student. And when I execute that statement, my prediction is a 64.5. That's pretty far off from the actual grade of that student, but it's still a prediction that's based on everybody's performance. So that's the basics for making a single prediction.